Today is May 7th, 2022, and it is a Saturday. And today I'm working on another problem with involving normal distributions and finding area below a certain point or lower than a certain point. So, a set of average city temperatures in May, May, are normally distributed with a mean of 20.66 degrees Celsius and a standard deviation of 2 degrees Celsius. The average temperature of Singapore is 26 degrees Celsius. So the question is, what proportion of average city temperatures are lower than that of Singapore's? So first things first, my objective is to visualize this because I always have an easier time doing this when I visualize. So I'm going to do from SciPy, import stats. I'll get into that in a second. Um, pyplot, CLT, import numpy as NP. So stats is what we're doing is we're importing libraries, and you can think of libraries that hold, it's basically libraries of pre-written functions that you can call and then use in your own codes. Instead of you having to write the function, it's already written for you, and all you have to do is call them. So stats has like various statistical functions, matplotlib has like plotting functions, and we're going to use that to graph our graph, visualize our graph. And NumPy is it's basically dealing a lot with numbers. So we're going to use that to get our x values. So I'm going to do NumPy. Oh, and by the way, we're importing it as NP. We're giving it another name because I don't want to be like NumPy dot. Instead, I could just be like NP dot, which is very easier to write. So I'm going to do NP dot linspace. So this linspace function in NumPy basically takes in three parameters. It takes in your the basically minimum value you want to start at, the end value, and how many values you want in between. So when you were graphing, you know how you have an x-axis and your graph goes from like a certain interval, so starting from like let's say -2 to 2, and then you have a whole bunch of values in between. Well, same thing here. We're going to start with one value, and I'm going to choose which values depending on the problem. So if I have the mean of 20.66, I might want to have to start with, let's say, like 15. So I'll start with 15 and maybe end at 25 and have maybe 1,000 values in between. And then if I run that, it's going to give me an array that starts with 15 and ends at 25, and it's going to give me 1,000 values in between. So if I scroll all the way up, it starts with 15, and then if you scroll all the way down, it ends at 25, but then you also see that there's basically 1,000 values in between those two numbers. And so I'm going to set that equal to my x values. What happened? Oops, I think I selected everything. Okay. So I'm going to set that equal to x values, a variable called x values, and then my y values. So again, the whole point is to get, your x and y values so we can plot it. Is going to be stats. So from stats, I'm going to use a norm function, and I'm going to use a PDF function from the norm. I guess not a function, but a method. PDF stands for probability density function. So I'm basically calculating the probability density of all these x values, right? And in respects to the certain mean and standard deviation that they give us. So mean is the same thing as log in this case. So they give us a log or a mean of 20.66, and then our standard deviation is scale in Python, and that is going to be 2. If you think about it, if you get confused between log and scale, you can always say, okay, well, scale starts with S, standard deviation starts with S, so scale is standard deviation, and then the one left is going to be mean. Okay, so I'm just gonna run that, and it's gonna give you nothing because all we did is set those things to variables. But now we're gonna use PLT, which is matplotlib, and we're gonna use the plot function, and we're gonna plot the x values, and we're gonna plot the y values. And you're gonna see when we have that, you're gonna see, what did I do? Okay, I delete that out, run that again. You should seek a fairly normally distributed graph because, well, it's telling us that it's normally distributed. So what does that mean? It means that it's symmetrical and that the mean is basically at the peak of that graph. So 20.66, it should be at the middle, right? Um, so maybe we want to do 30. So it's kind of more, oh, not 305, I said 30. Okay, what am I doing? 20, 25? And that's like a little 27. Okay, I think that's better. Yeah, 27. So I'm gonna save this image. Actually, hold on. We could still add a few things here. We can add a title. So I'm gonna do plt.title. When it wants to load. And that's gonna appear at the top. So normal distribution. Let me search up the mean symbol. No, I want mu symbol. Okay, let me go back here. Mu of what? What do we have it as 20.66? And let me search up sigma symbol over here. So we have sigma of 2. So that's, if we run that, that's going to just give the graph a title. We can do plt.x label to label the x-axis, and that's going to be in context of the problem, which is pretty much average city temperatures. And then run that, you're going to see that at the bottom. And then we're going to do plt y labels. Y label, I'm just going to call that density because we calculated the density of each average city temperature. And I think that's good. We can be a little specific and be like in Celsius, but whatever, it's fine. So I'm gonna right click, save this image, and then the second part of this um, problem or this video, I guess, is to actually answer the question of what the proportion is of average temperatures in Singapore that are lower than that given point. What date is it? Oh, the 22. Okay, so let me go to my whiteboard and upload an image or the image. If I could ever find it. Let's see. It's not there. What about quick access? Here we go. Okay, so this is what the image looks like. I'm just gonna go ahead and lock it. Okay. So essentially, if we go back, we know that the question is asking what proportion of average city temperatures are lower than that of Singapore's. So, oh, so it's not in Singapore. Okay, my bad then. Let me get my pen. So Singapore's temperature is 26. So it's right here. This is Singapore's temperature. Um, or average temperature. And they basically want to know what proportion of average city temperatures are lower. So that's basically all of this. All of this. All of this area. That's all of the temperatures that are lower than Singapore's average temperature. And so how do we find this area? How do we find this number? Well, there's two ways we could do it. So I'm going to show you how to do it both in Python and in your calculator, and the differences between doing both of them in their respective and the differences between doing it in Python and the calculator. So the function is called normal CDF. So you get this in your calculator by going to second vars 2. So click 2, it should be normal CDF, and then it's going to give you a few options. So it's going to give you lower, upper, if you're using a TI-84. If you're using a TI-83, I think it gives you this, and you're going to have to just know what values to put in between, but we'll do TI-84 first. So lower, upper, then it asks you for your mu and your sigma. Whoops, what happened? And your sigma, and then if you're doing TI-83, it's going to ask you for your lower bound, your upper bound, your mu, and your sigma like this, but these are not going to be there. You're just going to have parentheses, and you're going to have to plug in those values. So what is your lower bound? Lower bound and lower are the same thing. So lower bound is basically the number that you're starting with. So where is basically, you're going to have to find an interval, right? This is what we're trying to do. And it's basically the interval of the area you're trying to find. So if we take a look at this, we know that a normal distribution goes on to infinity in both sides. But we are just trying to find from negative infinity all the way to 26. So that is the area, that is the proportion of all city temperatures that are lower than of Singapore's or that of Singapore's. So our lower is actually going to be negative infinity, but since we don't have negative infinity in our calculators, we're going to use negative 1e99, or some people just use big numbers like n, like 9999, whatever, whatever. But I just use negative 1e99. So in this case, your TI-83, correct me if I'm wrong, but I believe this is what a TI-83 asks you for. So negative 1e99. What is your upper bound? Well, in this case, it's going to be where you're ending, that you're going to end at 26. Your mean is given to you, so it's 20.66, right, over here. And your sigma is 2. So in this case, your upper bound is 26, 20.66, and then 2. So that's what you do. And then in your TI-84, there's a paste button. You hover over it and you click enter. And then over here, you just click enter, and it should give you a certain value. And that value is the area under your curve, and that is your answer. Now, in Python, it's a little different. It's the same function. So the function we get by doing stats.norm. So again, it's a normal function, and instead of PDF, we're going to do CDF. So this is the same thing as normal CDF. So in here, this function in Python only takes 3 parameters in comparison to your calculator, which takes 4 parameters. Here, it only takes the point that you're trying to look for, or what do you call it? Like the point that you're trying to find an area above or below under. In this case, it's going to be 26. So it takes that point, and then, oh, my computer's frozen. We're gonna have to wait. Okay, so 26, and then it takes your mean, which is 20.66, and it takes your standard deviation, which is 2. And you're just gonna have to know in Python that CDF only takes the area below a certain point, below whatever point you put in here. I'm pretty sure it's X. Yeah. So they call it X. So whatever your point is, it's going to be X. So you're trying to find the area below X. That's the only point you're going to put in there. And you're just going to have to know that CDF only calculates the area below a point. So this is perfectly good for this example. But what if you wanted to know the proportion of average city temperatures that are above a point, above X or above 26 in this case? You're going to have to do 1 minus all of this, and obviously that's going to give you the opposite, which is above a point, right? So that's going to give you that. Okay, that's just for future reference, but really this is the proportion that answers our question, and we're going to round it to 4 decimal places because that's what they tell us to do in Khan Academy, and that's going to be your answer. So if we put that in there, it should be right. Okay, so that answers your question. Is there anything else that I want to say? Um, well, yeah, not really. Well, yeah, that should be the same number that you got on your TI-84 and your TI-83. But yeah, in Python, just to have kind of like a review, it's the same thing, except that it's stats.norm.cdf, and you just have your x, which is your point. So in this case, our upper bound is x. Our upper bound is x, but our calculator doesn't treat it as that. So it's just your x, or your upper bound, right? But note that your x is not always going to be your upper bound. So if they were to ask, oh, what's the proportion of average city temperatures that are higher than Singapore's average temperature, then X, this 26 would actually be your lower bound because that's where you're starting at. So think of, like an interval, right? So you're starting at your lower bound and ending at your upper bound, right? So in this case, you would start at 26 and then you would go to 1e99, positive 1e99, right? But we did the opposite. We wanted below that. So we started at negative 1e99 and ended at 26. So that's the difference. So that's why I'm saying I don't want to call it upper bound, but in this specific case, it's your upper bound. But it's not always going to be your upper bound, okay? That's only if you're trying to find the area below um, that X point. But yeah, so you have your X. Wait, what did I do? Okay. In this case, so let me write that. In this case, so you have your X, and then it's just going to ask you for your mean, your mu, and your sigma, your standard deviation. And then, yeah, and you're just going to have to know that it calculates below. Um, so this is for area or proportion below X, um, which is a point or below a point. Okay, hopefully that I explained that well. So yeah, bye.